All right, and we're back. This is episode 4 of my multi-cloud network architecture series. So before we move forward with the tasks for today, I just wanted to review what we did last week. And basically, what we were doing was building out a multi-cloud encrypted transit and basically a full mesh backbone across all of these different cloud service providers, these different regions and cloud service providers. So US West 1, US East 1 in AWS, and then Azure and GCP. All the routing was configured for us, all the IPsec was done, it was all orchestrated. We built this in literally 20 minutes. I could have built it in 20 minutes or less, but I was taking my time so that you guys could see things clearly. So quite amazing. To do this manually would take hours, if not days. It's not an easy feat to do on your own. So today, we have some new requirements. Let's go and take a look at those requirements together. And here are the requirements for episode 4. Since COVID-19 has taken over pretty much the entire world, we're all stuck at home, isolated, quarantining ourselves. And so what are we going to do? We're going to use the internet. We're going to get on the internet and we're going to do things like watching videos on YouTube and Netflix. We're going to do video conferencing with Zoom and other products. But you know what? I'm pretty sure a ton of us are going to be on dating apps, swiping left and right, getting our swipe time in, right? This is a good time for people to get that in. And so that means Dana Systems application, our dating app, is exploding, is taking over, and there's a ton of daily active users now. And so me as the CEO, I'm putting down some new requirements. I'm a pretty technical CEO. Usually CEOs don't do this stuff, right? But I'm a technical guy, so I like to be involved with my cloud architecture team. And so I'm telling them that they need to connect our primary data center 1, to AWS. And we'd have to do this via leveraging a 10 gig direct connect. But since a lot of the data that goes across the cloud to on-prem is personal information or credit card information, we need to make sure it's encrypted end to end. That means that 10 gig direct connect is going to have to be encrypted, and that's a challenge. Usually when you encrypt a direct connect, that encryption point is terminated in a cloud construct like a VGW in AWS. And when you do that, you limit yourself to 1.25 gig of throughput. That's just the way IPsec tunnels terminate in the cloud. That's how the limitation that we have there. And to go above that limitation, you have to enable ECMP if it's even supported in that scenario. And a lot of times it isn't. It depends on how it's being terminated in the cloud. And even if you do ECMP, you can only reach a maximum of like 5 tunnels or something, 4 tunnels. There's some limitations in here. And so we have to find a way around that. Number 2, we have our secondary data center in a different region, and it needs to connect to Azure. And we are going to leverage an Azure ExpressRoute. And then lastly, we have a lot of marketing users in the East Coast, across a bunch of East Coast branches. We acquired a company that does really good marketing, and so we're integrating them into our organization, and we need to connect them to the cloud where all their apps and workloads live. And so we need to figure out the easiest way to onboard them into the cloud, the most optimal and easy way to onboard them. And we can't spend additional money right now because it's COVID-19. We're furloughing and letting people go, right? We can't spend a bunch of money. And so we're going to have to figure out how to do this without buying a bunch of new hardware, like a whole new SD-WAN solution. We just can't invest in that right now. Maybe down the line we'll invest in that, but right now we can't. So we have a bunch of ISRs, old iOS and iOS XE devices. We got to figure out how to onboard those in a nice, easy, manageable fashion, okay? So let's go back to the diagram and see how we're going to meet these 3 requirements and what we're going to configure in the orchestrator to do this for us. So if you didn't notice earlier in this video when I showed this diagram, there's some new stuff that we've added, and it's here, southbound, and it's in the access layer of the multi-cloud network architecture. That's what we're working on for this video, the access layer of the MCNA. Do you guys remember what the access layer was? I'll show you that in a second. But take a look at how we're going to meet those requirements. Requirement number 1 was to have the Direct Connect and Data Center 1 connected and have access into the AWS environment. And do that with 10 gig and also encrypt 10 gig. So how do we meet that requirement? Well, traditionally, it's not easy. There really is no way to do that unless you leverage Aviatrix CloudWAN solution on-prem. And so what CloudWAN is is basically our virtual gateway that's running on a super beefy server that you place in line in a Direct Connect environment in on-prem, either in a co-location or at your data center, and it can terminate the 10 gig, and basically it will build a ton of IPsec tunnels, and it'll do insane mode encryption, which means it builds a bunch of IPsec tunnels, and we do equal cost multipath across all of them. And so the aggregate encrypted transport flow throughput is going to be 10 gig, right? So now we don't have to worry about that 1.25 gig limitation because we're terminating it on a on-prem cloud end router, and in the cloud we're terminating those IPsec connections on the Aviatrix gateway. So what we're doing is we're leveraging the 10 gig as just a transport, and we're passing those IPsec tunnels through the VGW. We're not terminating on the VGW. If you terminate it on the VGW, you get stuck at that 1.25 gig limit again. So we're passing through it. It's just a router in the path of traffic. It's another hop to us. So now we can terminate 10 gig. We can get that connectivity up and running. So that is that's solved. Now the second thing was Azure. We need to onboard Azure into Data Center 2, and so that's a simple configuration. It's really just leveraging a normal ExpressRoute configuration from our transit environments into the on-prem. Now I don't have an ExpressRoute, okay, so I also don't have a Direct Connect. I'm just going to simulate those transports, and I'll just use the internet and build an IPsec tunnel. In the end, it's the same idea. It's the same thing. It's basically the same workflow. There's a couple more radial buttons you'll press, and it'll do it for you. But in the end, for this lab environment, I can't go and buy a bunch of ExpressRoute and Direct Connect. I don't have the budget. So it's the same thing, right? We're building connectivity from Data Center 2 to Azure, Data Center 1 to AWS. And then we have all those marketing branches. Remember, we have to onboard those guys. And we're going to do that over the internet. And we're going to do that without having to spend a bunch of money, because we already have a solution in Aviatrix multi-cloud network architecture that's called CloudWAN. And what CloudWAN can do is reach into the router. The orchestrator will reach into the routers, the iOS and iOS XE routers, and configure them. It'll handle configuration lifecycle and configuration management, rollback, different revisions of the configuration. It'll configure the IPsec and the BGP and the routing, and it'll also leverage AWS Global Accelerator. That's the optimal connectivity requirement. We're going to ingress to AWS in the most optimal fashion. Global Accelerator is basically an Anycast solution, and so it's going to call home. Basically, these IPsec tunnels will terminate onto an Anycast IP, an AWS Global Accelerator IP that will then get forwarded to the edge VPC it's trying to connect to. So it's going to ingress to the closest AWS point of presence and then ride the AWS backbone, which is a congestion-free, high-throughput backbone, to terminate its connections on the correct edge VPC. Now imagine how cool that is. Now you don't have to take a bunch of random hops over the internet to get to what might be not the most optimal ingress into your cloud. We're going to ensure that you have the most optimal ingress into the cloud by using Global Accelerator. All right, so let's get started. Let's start configuring this stuff in the UI. Now I'm going to pre-configure some of these environments, like the Data Center 1, Data Center 2, the CloudWAN branch sites. Those are all just going to be some VPCs that I'm spinning up and simulating on-prem. I'm going to throw some CSRs, some Cisco CSRs in there to terminate IPsec connections as like basically as an ISR, or as an example direct connect termination point. Same thing in the end. But actually I have access to a cloud end virtual image, so I can pretty much terminate an IPsec tunnel on that cloud end. Now I haven't tried this myself, so I'm going to try it out before so I don't look like an idiot doing it live, make sure it works. And then we'll come back, I'll get all that stuff set up, and we'll build the tunnels and the configuration in the UI together. I just want to pre-position some of the stuff so we don't waste too much time. All right, so let's get to it. All right, and just like that, I've spun up our on-prem environments using VPCs to simulate them. So I have a VPC for Data Center 1, and that CIDR is 10.51.0.0/16. I have a VPC for the CloudWAN branch, and its CIDR is 10.50.0.0/16. And I have a VPC for DC2, and its CIDR is 10.52.0.0/16. Now it's a good thing that I went and tested some stuff out, because turns out I can't. There's no native AMI for Cloud N. Yes, it's a virtualized platform, but it's designed to be placed on a server, so it runs like in OVA or KVM or whatnot. And so I'd have to convert those OVA or KVMs to an AMI. I don't have the time or the patience to do that now to run that in a VPC in Amazon. So I'm just going to simulate that DC1 Cloud N box with a CSR, because in the end it's the exact same process. It's really no difference in the work in the UI, and so I just want to show you how it's deployed, and it'd be the same thing as if you were deploying a Cloud N. There's some specific things on a Cloud N that you'd locally configure on the box itself, but really for the purposes of this multi-cloud network architecture demonstration, it makes no difference at all. I just want to show you how easy it is to build on-prem connectivity and get the end-to-end routing in place through orchestration. All right, so let's jump into the UI and start configuring some of this stuff. Okay, so here we are in the UI. I wanted to show you something real quick before we jump into configuration. Under the Useful Tools section and VPC Tracker feature, we have a little bit of a pseudo IPAM feature, which I just love. It's really fantastic. So what the orchestrator or controller is doing is it's reaching out and reading and pulling the native cloud construct information via APIs. And so it's actively always checking to see what you're deploying out there, what CIDRs you've configured. And so we can do a quick search on those CIDRs that we configured and see what they are, right? So if I hit, it's kind of a live index here. If I type 10.5, you can see it now indexed and showed me the 10.50, 10.51, and 10.52 networks, and tells you where they've been deployed, right? Which in the VPC name and the VPC ID and how many instances are there. Now, I have spun up a workload or a PC instance in each one of these, as well as the CSR that's terminating the connectivity, so that I can have a test point. I want to be able to test past the CSR that terminates the IPsec and get end-to-end connectivity. So that's why it says there's 2 instances in there. But it even tells you the account it was used to create, you know, where it's in, and then the region it's deployed in. This is a fantastic feature. And let's say you had like thousands of CIDRs deployed, which is not uncommon, you can search for a CIDR to see if it's been used before. I know this has been used, but I'm going to check to see what it says. There, it says, oh, bad news, that CIDR has been used in the DC2 VPC that I'm about to leverage, okay? So this is kind of cool. I love this feature. I wanted to just quickly show it to you. So let's go, and first thing we're going to do, let's go back to the diagram here. Let's build this out right there. That's the Cloud N Direct Connect feature. And what we're gonna have to simulate that, however, with a CSR and just a normal IPsec tunnel. But I'll show you what that workflow would look like. So if I go back to the transit network section, because we're connecting it to a transit network, and click Setup, and I scroll down right here, it says Connect to VGW, external device, or Aviatrix Cloud N. Now, if I did have a Cloud N, like I had a server at my house, or I was running it on my Mac. My Mac's pretty crappy. It's going to go 8 gigs of RAM, and so it would probably crush it. And I don't want to kill my Mac as I'm recording and doing a bunch of other things. But you would click this radial button here called Aviatrix Cloud N, and then you'd specify, well, where you're connecting from where to where. Well, I would be connecting from the West Transit, and I'd give it a name, maybe Cloud N. And then I would specify my local ASN for BGP, because we're going to run BGP on top of that tunnel that we build to the Cloud N. And so you can give it whatever you want, whatever private ASN you want to place there. And then in this case, I'm thinking I'm going to use 6500.003. I think that's what I have configured. I'm using this for some other AS for another use case for a colleague of mine. I was testing some things for him, but I'll just keep using that same ASN. Then you specify which gateway you're going to leverage, and there's only one transit in that particular region or that particular VPC, and then you go through and add all the different features, right? So of course, this is Aviatrix Cloud N is going to be over Direct Connect most of the time. You can also do it over the internet if you wanted to get high throughput internet VPN tunneling. We support that as well. But in this case, you'd select Direct Connect. Yes, we want insane mode, so we can get the full 10 gig throughput, encrypted throughput. And then you specify the Cloud N's peer ASN. So that would be maybe 65006 or something, right? Whatever the peer N side is, and what its WAN IP address is, and then the LAN side. And so basically, you go through and configure all the these boxes, and then you hit connect, and it builds it out for you. And so it basically configures the transit gateway to have an IPsec tunnel trying to connect to your Cloud N, as well as a BGP peering relationship trying to come up in that environment. Now, I'm not going to do that here because I don't have a cloud end, but it's the same process. So let's just go over to external device, because that's what we're going to do. We're going to connect to a CSR. So yes, external device, yes, BGP, yes, we're doing that from the West Transit, and let's give it a connection name. Let's say this is CSR DC1. Oh no, DC1 CSR makes more sense, right? So, and let's say I'm going to configure him as 6500010. 65010. It doesn't really matter. And then, oh, wait a second. No, that's my local one. Sorry, 65003 is correct. I need to keep that 65003 because I'm already using 65003 for something else on that transit, so I can't have multiple ASNs in BGP. So in any case, here's the primary cloud gateway, and then you can, if you wanted, you could specify different algorithms. I'm not going to do that here. I'm just going to use the default algorithms for IPsec and ISACamp. And then if you had multiple remote gateways, multiple CSRs, you could do that. I'm not doing that in this case. It's just a single CSR. And if you want to run this over Direct Connect, you could do that as well. But I'm going to keep this pretty simple. My destination CSR's BGP AS number, let's do 65010, like I said before. And then I need to get its remote gateway IP. So let's go back to my AWS console, because off the top of my head, I don't know it. And let's make sure we're in California. Yes, we are. So that's great. Let me find EC2, and let's see what that IP address is, because off the top of my head, I do not know it. So DC1 CSR, that's the one we're going to connect to. Here's the private. I need the public. There he is, or she is, whatever you want to call an IP address, whatever sex the IP address is. I don't know. So it's 54.151.122.232. I'm going to copy that. I'm going to go back over here and pop it in this box. And then I'm going to give it a pre-shared key. Now, it'll auto-generate a really long, secure pre-shared key if you leave it blank. But I'm just lazy, and so I'm just going to do Dana123 Dana, and I'll let it auto-generate the tunnel IPs for me, the private IPs for the IPsec tunnel that gets built up. Now, the last option here is edge segmentation. What this is if you wanted to carry segmentation from, let's go back to the Lucid chart to show you that. Basically, if I wanted this to land on a specific segment in here and carry that segment so that it could only talk to certain VPCs, you could do that if you wanted. So that's our segmentation model, part of our segmentation model. It's one of the functionalities in our segmentation. We have quite a few other functionalities. So in any case, that's it. That's all you need to put in there. So let's just click, let's make sure it's all good. We got the BGP, we got that, we got the name, we got the AS number, we got the destination AS number, the destination IP address, and pre-shared key. That's all we need. Let's just hit connect. Yes, I want to connect, blah, blah, blah. Okay, good. So give it a second. I'll pause the video and we'll be back once it's done. It doesn't take too long. And we're done. Look how quick that was. It really actually only took about 15, 20 seconds. Okay, so now that it's done, you might think, well, I got to configure the other end, which is the CSR. It's my on-prem device. Yes, that's correct. Now, we're going to give you some help, though. We're not just going to leave you on your own to do that. I mean, you could figure it out. It's pretty straightforward iOS configuration. But if you want to know how to do it, you can go to the site to cloud section. This is where all those site to cloud tunnels are going to be configured. Forget about these up ones. Those are for another use case I'm doing for a customer. I'm testing some stuff out. But we're focused on this one. It's down right now, of course, because we haven't configured the remote end. So let's just take a look at it. Let's click it. And then what we can do is we can go and generate the detailed configuration output so that we can leverage it when we're building our iOS config. So let's hit generic. It's not Cisco because Cisco is only for, we have an ASA template. But if you hit generic and leave all this stuff as default and click download config, it downloads the config. I'll open it up. And what this is pretty much all the information you need to go and configure the remote side. So it tells you, tunnel 1, what the IKE SA information is, what the IPsec SA information is, so you know what to configure. It gives you the IP address, the public and private IPs of both sides and of the tunnels, and it's just some configuration information about MTU and pretty much anything to do with whatever it takes to bring up that tunnel, right? MTU and the DF bit information and all that stuff. Okay, and also the AS information. So it does it for both tunnels, tunnel 1 and tunnel 2. So then you can go and manually build your IPsec configuration on your iOS device, and it will come right up. Now, I'm going to pause the video and do that myself because, I mean, it's not that hard. I'll show you the config once it's done, but I don't want to take the time here showing that because really anybody can figure that out just by reading documentation or looking at a template. It's very easy. Actually, our docs.aviatrix.com shows you a template that you can follow to do that. So give me a second and I'll be right back. So let's throw that configuration on the DC1 CSR. And remember, the DC1 CSR is simulating the cloud end because I don't have access to a cloud end right now, but it's going to simulate cloud and IPsec tunnels over Direct Connect. And I don't have a Direct Connect because I'm not rich, and so I'm just going to use the internet, and it's going to terminate on our gateways in the West Transit in AWS. So I have a CSR here, going to configure the IPsec tunnel on it now. All right, let's do that. Let's bring up the CSR. You can see right now, if I do a show run, there's really nothing there. Nothing there. So show IP BGP. If I can spell BGP right, no BGP. Show IP interface brief. No tunnels. Right. So I'm going to configure all that right now, and we'll see everything come up in just a moment. So let's go grab. I do need to make a quick change to something. I used the wrong AS number before. I used 65003. I need to use 65009 because I'm using 65003 in the East already for some other use case, so I need to use a different AS. I don't want to have the same AS. So, all right, so 65009 is my transit, and 65010 is my DC1. So let's grab the whole config, and if my Cisco skills are still good after leaving Cisco in January, it should come up. Let's see. All right, any errors? Nope. All right, my skills are still good. So if I exit here, do a show IP BGP. Oh, look at that. We got some routes coming in. Show IP BGP summary. There we go. There's my BGP peerings. They're up with 65009, which is the two transit routers in the transit West Transit environment. If I do a show IP interface brief, my tunnel should be up. Yeah, we're good. Everything should be fantastic. Let's go and validate on the Aviatrix side. So we know the Cisco side is good. We're receiving routes. Actually, if I do show IP BGP, we can see 10.1, 10.2, 10.3, 10.4, 10.5. Those are all those different environments that I built out in different networks, right? So we had the ones for AWS, we had in Azure, we had GCP. So we're seeing all those now. It's all good to go. So let us go and take a look at the Aviatrix side. So to validate this, we want to go to the site to cloud section, and we can see that our tunnel is up. DC1 CSR tunnel is up. Great, that's fantastic. You can see some details about it here, but we want to go deeper than that. I just don't want to end there. You can run some diagnostics from here if you want, but what I want to show you is the BGP diagnostics. So if we can actually go to the list section here under transit network, and we can select that West Transit router, or either West or West Transit or West Transit HA gateway. We're going to hit show details, and we're going to look at the routing table. There's a bunch of summary data here around what routes are being learned from where and whatnot, which is nice for a quick view, but you know, I'm a routing guy and I like to look at routing tables all day long. And so let's take a look at the gateway routing table. And so if I scroll down, we should see the 10.51 network, right? If I go back to the Lucid, 10.51 is my network down there in the data center. I should see a subset of that network right there. 10.51.64.0/20. That's where my workload lives. It is going down the DC1 CSR IPsec tunnel. That's the site to cloud tunnel. And you can see there's actually two paths. There's one path directly, which has a metric of 100, and then we have another alternate path through the HA gateway the buddy next to me with a higher metric. So I have an alternate path in case my path goes down. So that's good. All the HA is set up. The routes are being learned. We can actually go and look at advanced config, and under diagnostics, well, first we can see what BGP peerings are up if you want to see that from here. See, they're established to the different environments. Forget about these other ones. This is for a different use case, but it's the first two we care about. It looks like they're established and up. But we can go to diagnostics and run some BGP commands, right? Because we run a full routing stack in here. So let's do a show IP BGP. And you can see that 10.51 right there. Perfect. It's got the caret, meaning it's the best path. And the next hop is that tunnel, the other side of the tunnel, on-prem, and 65010 is advertising it. That's my on-prem AS. All good to go. You can run other BGP commands in here if you want to get more information, but that's it. That's what I wanted to show you from the perspective of validation. So everything seems to be good to go here. Okay, so let's work on the next task, and that's getting our marketing branch sites connected to the cloud. And so we want to connect via the most optimal ingress point into AWS and have it ride the AWS backbone. And so to do that, we're going to leverage CloudWAN. What CloudWAN does is it uses our controller to reach out into the ISRs that are living on-prem and configure them with BGP and IPsec to tunnel back to the closest point of presence in AWS using AWS Global Accelerator. You can go learn more about that online if you want to know how Global Accelerator works. But it's going to ingress the closest point of presence, ride the AWS backbone to hit our transit gateways to terminate the tunnels there. All right, it's going to hit this East Coast transit gateway setup. All right, so what we want to do first is we want to go to the workflow of CloudWAN and register the router. So let's give it a name. Let's call it CloudWAN. Oops, I should probably use some nice typing here. CloudWAN branch 1. And we need the public IP of that guy. So I have it ready here already. So let's grab it. There's a public IP of the CloudWAN CSR on site. So we can reach out and manage it. And it's an iOS device. So today we only support iOS. Maybe in the future we'll support more types of routers, Juniper or HP, I don't know, whatever is in demand, I guess. And so the next step is to specify, is it being configured via private key or a password? In this case, it's private key. So that's user is my username. I'm going to select my private key right there, and it's going to connect via port 22. And there's some optional information here as well. Let's say you wanted to create a description or tell the UI where that device lives. You can leverage that as well, where its address is, and so you can differentiate between remote sites and give them names and things like that. So we're not going to do any optional information. We're just going to register it. Done. My next step is to go to the attach. So under the attach workflow, first thing we need to do is prepare to attach. And what it's going to do, after clicking Discover WAN interface, is it's going to look for any eligible interfaces where it could build IPsec and BGP tunneling, IPsec tunneling and BGP peering on. So let's give it a second to do that. All right, it looks like it found Gigabit Ethernet 1. That CSR only has one interface on it. And you'll notice that it pulled the private IP from the configuration. We need to use the public. We're trying to build the tunneling to the public IP. So let me grab the public again. In AWS, you're behind NAT, so that's why I did that. So yeah, oops, that's not the right one. Sorry, it's this one. Almost made a mistake there. So it's that one. All right, I'm gonna hit apply. Done. Next step is we need to attach that branch that we just configured in here to the transit gateway of our choice. Now you can configure and connect it to the Aviatrix transit gateway or an AWS transit gateway if you're leveraging the AWS transit gateway in AWS, or Azure Virtual WAN. Now this feature, Azure Virtual WAN, is coming very soon. It's not in 5.3. I believe it's in 5.4, which is our next release here very soon. But yeah, we have very many options to connect into your cloud environment. Most people are going to use the transit gateway because you get a lot of cool functionality like visibility and security and additional, you can do like NAT and all sorts of additional things with an Aviatrix transit gateway because it's a fully fledged service node in the cloud with a lot of services. So we're going to connect to that. So you select the branch. We're doing branch 1, which we just registered, and then we're going to select which transit do we want to connect to. We want to connect to east. Remember, if we go back to the Lucid, we're connecting to the east coast, my east transit. So connect to the east one here and give it a name. Let's say it's east transit to BR1. Okay. Then you got to specify the transit gateway's autonomous system number for BGP. And this is where I made that mistake earlier. I got to use 65003 because I've used it before for another BGP connection earlier. You can't have two different ASNs on the same router. So 65003, and then my branch, let's give it a new guy, 65011. We haven't used that yet. Okay, and so we don't need to specify any algorithm unless you really wanted to have a specific algorithm to use there for IPsec. And yes, we do want to enable the global accelerator. That's good, so that it connects in. And then really, I'm going to leave everything else blank. It's all I need to do. I don't have another router there, only one router. If you had two routers, like you wanted to have HA, you could connect that, and it would configure 2 tunnels to each different router. But in this case, we're just going to click attach and see what happens. All right, configuring IPsec tunnel on the gateway east transit, configuring IPsec tunnel on gateway CloudWAN BR1, which is my router. So it's already reached into my router. Remember before I showed you, or I think I showed you, there was nothing running on that router. But after I hit a show run, you'll see there's going to be a bunch of stuff. And I haven't done any of it. The controller did all of it. All right, it says it's done. Do I believe it? Yeah, I believe it. Let's go and take a look at that guy now. If I do a show run now, what do I have on here? Let me zoom in a little bit for you guys. Ooh. I have a crypto key ring, so I have that configured. I have all my crypto ISACamp information, my IPsec transform sets, my profiles, my tunnels, my BGP. I didn't do any of that. It did it all for me. Isn't that beautiful? So if I do a show IP BGP, I should have something up. Show IP BGP summary, sorry. If I can spell right. Okay, it hasn't come up yet. I'm going to give it some time to come up. Okay, there it is. It's up. I just need to be a little bit more patient. When it wasn't coming up, I started to freak out, and I just need to have a little more patience. And a couple seconds later, it came up. So we're good to go. You can see I have both my peers up. That's my single CSR to the gateway in the east and the HA gateway in the east. And if I do a show IP BGP, you can see all the routes, 10.1, 10.2, 10.3, 10.4, 10.5. Those are all my workload environments across different regions. And also I have my 1051.64.0/20, which is my Datacenter 1 environment. Okay, this is great. I'm starting to learn all my routes. Everything is working end to end. Now let's go take a look at verifying things. So if we go back to the UI, we click list edit, you can see that my Cloud1 branch 1 is attached. Fantastic. Isn't that awesome? It's all good to go. And then if we go to the config tag section, we can actually build a tag and then apply a tag to a router. And what a tag is a set of CLI. It's like a template, right? Let's say like the banner, I don't know, banner MOTD. So let's create a tag called banner, and let's put some config in there. It's like banner, I don't remember how to do with banner MOTD. Do you guys remember how to do that? I forgot. Config T, banner, MOTD. And you have to give it a little thing, right? A little delimiting character. So let's do where C banner is. Okay, C is delimiting character. Dana is cool, and then we'll do C again. So I'm gonna take this. Oops. I'm gonna take that and pop it into my thing here. And I'm not gonna configure it from here. So let's grab. Let's just delete it because I don't want it there. I'm gonna throw it in here. Banner MG C. Dana is cool. C. So if I hit save, that's now there. Now I can attach a template or config template to a router if I want to add additional functionality or additional config. So let's click banner, and I want to attach it to this guy, Cloud1 branch. So click include and click attach. Okay, then I'm going to commit it. All right, commit. Yes, I want to commit it to those branches. Hit OK. So it's going to push that config out now. Now if I go back here, if I do a, remember I didn't hit enter here, so I didn't configure it from here. So if I do a show run, eventually that should show up here once this is done. All right, it says it's done. So if I do a show run, that banner MOTD should be in there. Wait, let's do a show run, include pipe, include banner. There it is. Banner MOTD. There, Dana is, oh, I guess I messed it up because cool has a C, and so the moment it saw C, it thought it was a delimiting character and stopped it. But Dana is, that's my banner. So when I log in, it would show that as the message of the day. So that's just a cool feature that you can add little templates to the routers that you're managing with CloudWAN. Now there's more to that as well. If I go to the list edit section and I select the router, I can go here and see a lot of different things like editing its config. You can save and restore the config. So let's edit its config, and you can see this is its current running config. I can manually edit that running config and add more stuff to it. Okay, or I can see the previous config and do a diff on the previous config. So let's do something quick and see what happens. Let's do a banner motd c Dana loves Aviatrix. I guess, right? Aviatrix C. And then hit commit and see what happens. All right, looks like it's done. So if I go back to the router, let's double check to make sure that changed. Yeah, there it is. Dana loves Aviatrix. So it changed it from here. Now I can also see the previous commit. If I click that, you can see here the difference between the old config and the new config is that it changed Dana is banner to Dana loves Aviatrix. You can see red and green, it removed and added. Pretty fantastic, right? I love that feature. Okay, you can also undo these changes by clicking undo. Now, we can also go to save and restore config. And so this allows you to have multiple versions of the configuration, different revision control, and then restore them like a rollback. You can have several different rollbacks. Now I'm not going to go through this because it's pretty straightforward. You can create a configuration name, save it, and then you can roll back to previous configurations. It's very straightforward and easy to control. But I just thought I wanted to show you that and how amazing it is. We also have AWS Network Manager integration. I'm not going to do that in this demo because really it doesn't matter, but you can connect. You can have this all show up in AWS Network Manager, which is some AWS functionality for geographic visualization and whatnot. You can go figure that out on your own and learn about it. But yeah, that's it. That's CloudWAN. That's how easy it was to onboard a router. You can do that over and over again for all your different routers in your network, or you can script it all via Terraform and get it done really quickly instead of having to click different things. All right, let's move on to the next section. Okay, and lastly, we need to get Datacenter 2 connected to the cloud via an Azure ExpressRoute. Now, of course, I don't have an ExpressRoute, so this is again going to be another CSR across the internet, but it's the same process. It really makes no difference as to the workflow itself. I'm going to add one extra requirement. I want to make sure that I have some sort of control as the routes from on-prem enter my cloud network. So in this case, I don't have access to the router to create a prefix list to block certain prefixes from being advertised from Datacenter 2. Let's say it's at a colocation and I don't have access to it, or it's an acquisition or something and I don't have access to it. I want to make sure I control which routes come in here so that nobody sends me overlapping CIDRs or a more specific prefix to mess up my routing within the cloud. And so we're going to enable route control. This is a really cool feature that allows us to whitelist or just ensure we see what routes are coming in first before it gets propagated anywhere else in the cloud network. So let's get started on that. So this process should start to look familiar. We're going to do the same thing as we did before. We're going to go to Transit Network, the setup page. We're going to scroll down to number 3, which is connecting to a V2W external device or Aviatrix cloud end. In this case, it's an external device because it's a CSR. And then we're going to do BGP. And we're trying to connect to the Azure Transit. Remember, if you look at the Lucid, we're connecting this DC2 to the Azure Transit network. So Azure Transit's already selected. We're going to call this Azure Express. Let's just call it Azure Express. We have to give that gateway an ASN because we haven't done it yet. So 65, let's say 65012. We haven't done that yet. And then yes, it's the Azure Transit. And then we're not going to change any of the algorithms or HA or anything like that. This is pretty straightforward. And then we want to give the remote AS a new one as well, 65013. Sounds good to me. And we need to get that guy's IP. So if we go over here, if we go to my EC2 instances, I gotta find that CSR's IP address. So DC2 PC, it's DC2 CSR, that guy. So let's grab it. There it is. It's a nice looking IP. So let's take that, throw it there. And we don't need to mess with anything else. No edge segmentation, nothing like that. Pretty straightforward. We're going to hit connect. Yes. So it's going to build that site to cloud tunnel now. Let's give it a moment. The configuration is done. It's pretty straightforward. You guys have seen me configure IPsec tunnels and BGP on a router before. So it's the same thing, just different IPs and ASs and stuff. So let's grab that config and throw it onto the router. And hopefully it comes up. Hopefully I did everything right. There we go. So we're going to check now. It should only take a moment for that tunnel to come up. Let's do a show IP BGP sum. There we go. Look how quickly that came up. So now the difference here is that on the transit side, we're not going to learn all those routes and propagate them everywhere automatically because I set up that route control. I enabled route control. So we have to go and approve the route that we're going to learn from here. In this case, the route we're learning, if we go back to the Lucid, where's my Lucid here? It should be 10.52.x.x, whatever it is. Off the top of my head, I can't remember. When we go and look at it in the controller, we should see that. Let's just verify and make sure the tunnel is up on this side. Still shows down. This just hasn't updated yet. Let's give it a moment. It should update. There we go. Now it's up. Okay, cool. So that shows that the tunnel is up. It's all good. Let's go and look at the route approval thing. We should see some route show up in there. Let's see. Pending, nothing yet. This takes a little bit of time after it first comes up. Let's give it a moment, and it'll be right back when it starts to learn those routes. There it is. Actually, it only took 2 seconds. But you can see here that it's got a route 10.52.176.0/20 is pending. So it's not going to send that anywhere else in the cloud environment until I approve it. So my gateway is acting as a gateway, right? It's acting as an ingress point, a secure ingress point where you can control routes coming from partners, from other VPNs, or in this case, a site to cloud VPN. So let's approve it. Let's get it over there to the approval side and hit update. All right, that's good. So we successfully approved that route. So now it will be in the routing table and propagated by our controller end to end in the cloud networks. So let's go quickly validate that. Let's go to the list section and let's take a look at that Azure transit and look at his routing table. Scroll down, look at his routing table. And we should see the 10.52 somewhere here. There it is, 10.52 across the Azure ExpressRoute that I had created. Azure Transit, also you can reach this through the transit gateway, which is the other tunnel right next to the, connected to the original transit, the primary transit router. So yeah, just like the other environment, we have 2 paths to get there. Let's also check the BGP. So let's go to Advanced Config, Diagnostics, Azure Transit, and run show IP BGP. You should see 10.52 in here somewhere. There it is, 10.52. Isn't that cool? We're learning that directly from 65013, so there's only one AS in the path. Now we're also learning 10.51.64.0, and we're learning that not through BGP. Honestly, actually, we're learning that 10.51.64 through our SDN gateway. Our SDN controller is telling us that, hey, you can reach 10.51.64 through these AS hops across, which is basically going to, if you go back to the Lucid chart, it's saying, hey, you can reach this guy through this buddy over here down that path. So it's telling you that your next hop is to go over here, and then you can follow that traffic or that path down to the DC1 to reach the 10.51 subnets. Now, what's cool about this is that we're taking the AS path and propagating that and making sure we retain that information end to end, so you can leverage that for loop prevention and for optimal path, like, making sure BGP takes the best path because of BGP. BGP is leveraging AS path primarily for that decision-making process. So that's it. That's pretty straightforward. Okay, so I have a test PC in Datacenter 1 called DC1 PC. I also have test PCs across the other environments. So I have a test PC in here, I have a test PC in here, and a test PC in here. So I'm basically just going to ping things from my Datacenter 1 because it's my primary environment. I'm going to ping from here through the transit, the local transit, over our encrypted backbone to the East Transit and down the CloudWAN network into the marketing branch. And then I'm also going to ping the same from the same source, but I'm going to go from here through the encrypted transit to the Azure transit and go down the Azure ExpressRoute and hit that down there. All right, so let's play with that now. And I should also be able to hit some of the workloads up here. Maybe I'll play with that as well. I didn't try that, but we should that should work as well. So let's go and test that out. So we can go log into my test environment
my test PC, which is in Datacenter 1. And so I can hit connect, go to the EC2 instance, hit connect. Let's give it a moment to jump in there. All right, so what we're going to do is ping the the CloudWAN site first. So let's go find the CloudWAN site IP address. I remember off the top of my head. Let's go to running instances. So under CloudWAN PC, I have an IP address right here, 1050.182.249. Let me ping that guy. 1050.182. I have this horrible memory. 249. So that should work. Bam. Look at the latency. You totally know this is going over a transit because it's not directly connected in the same environment, right? So it's going across a region and it's hitting the hitting the east transit, and then from the east transit it's going down another IPsec tunnel to the CloudWAN CSR and then hitting the PC down there. So that works perfectly fine. So let's also test the PC over here through the encrypted transit over to Datacenter 2. One thing to notice here is that it looks like these are all like in the series. Like it goes from here to here and then it goes from here to here. This is not I'm not doing a transit network like that. I actually have a full mesh of tunnels. Remember from the beginning I built a full mesh between all these different, including GCP. It's hard to display that in a diagram, so I just have these lines looking like that just to show that everything is connected. So really it's going to go directly through an encrypted tunnel to each appropriate transit to get to the workload. So it's taking the most optimal path. It's not like it's jumping through another cloud environment to get there. Just wanted to mention that. So let's grab that IP address of the Azure workload. So that should be DC2 PC. Where's that? That guy right there. So let's take its 1052.189.251. Should be able to ping that too. Ping 1052.189.251. Bam. Again, same thing. It's a little bit of a higher latency because it's not in the AWS network. It's going to Azure, so it has to go down. It's not like staying within the AWS backbone in that case, right? So a little bit higher latency, about 10 milliseconds. Not a big deal. That's great. So all that connectivity works. The last thing we need to check is connectivity to the workloads themselves, not from site to site, not on-prem to on-prem. I want to check from on-prem into the cloud. So let's go grab a test PC. I think I have, yeah, like east workload. Let's hope this works. 10.2.207.213. That's basically, I open my Lucid. That is a workload living here. That's this workload right here. So I'm going to go from Datacenter 1 up this transit, up the Direct Connect, across the transit into that workload and back. So let's try that out. I forgot the IP already, so let's go grab it. 10.2.207.213. Oop, too many windows. Ping 10.2.207.213. Bam, look at that. I didn't even test that. It worked perfectly fine. All the routing for us is done end to end. I didn't configure a single route this entire time. It was done for me, end to end, for all these prefixes. It's just mind-blowing. I don't have to manually configure anything anymore. It's all orchestrated for you based on your intent. Your intent is that I wanted to connect this region to that region, this workload to that workload, this secure domain to that secure domain, and the orchestrator will figure it out for you and configure it end to end. Imagine how much time you're going to save from a deployment and troubleshooting perspective using Aviatrix controller. Let's test one more thing. I want to test GCP. I want to go all the way into GCP. Now, I don't remember the GCP workload IP, so let me grab that. Let me pause it for a second and grab that, and I'll be right back. The GCP workload IP 10.5.0.4 is going to be our test IP, and what we're going to do, go back to the Lucid, is we're going to test from the PC living in Datacenter 1, go up our CloudN Direct Connect IPsec 10 gig high throughput encrypted tunnel all the way to our AWS West Transit, and then take an active mesh, our backbone, our encrypted backbone transit all the way directly to GCP transit and then up into their workload and back. All right, so let's test that out. It should work. Oops, that's not what I want. Let's test it out. Let's stop this one. So ping 10.5.0.4 is the workload. Bam. Perfect. Works. No problem. And actually, look at the latency, how great it is 45 milliseconds around there. That's better than the AWS to Azure latency. That's pretty fantastic. Or the Azure to AWS inter-region. So this is actually quite fantastic latency. Google does a great job with networking, it seems, because in a previous test I did with you guys, Google had fantastic latency as well. So I want to drive home the point around what this platform is doing for you and how it's saving you so much time. This whole setup I just did, if you were to do this by yourself without our automation, without our tool set, without our functionality, it would take weeks, forever. It takes a long time, and it's such a manual process. So many static routes, so many IPsec configurations you have to configure, so many instances you have to spin up, and all this connectivity. It's so manual. And the way we did it was all automated, just a workflow, and we configured everything end to end: security groups, IP route tables, the IPsec tunnels, the BGP, everything for you. Imagine the amount of time you can save using Aviatrix as your organization's multi-cloud platform. So I'm really happy to see this work the first time around, and I hope you join me for my next episode where we're going to make this even more complex. We're going to add more and more complexity coming down from Dana, the CEO of this fictitious company, and we're going to have more fun. So I'll see you guys next time.